let's keep looking for our last one.
Yeah. Interesting.
Again, this is saying at 15 students, we're having 1.5 adults. So I don't know how you get 1.5, but whatever. Maybe you can cut somebody in half. Hopefully Israel is not me.
Dude.
But at 30 students, saying 1.5. Well, it's
so
not rising because the more students you have, the more
that was the last part. Let's do the last part. Let's finish this up. So ABCD, rotate 180 degrees clockwise about the origin to form A prime, B prime, all that. What statement is true? So when I first looked at this, I thought we were going to have to move all these points 180 degrees down here. But we don't. But what if we wanted to anyway? So point A was at 5, 5. Okay. And if we go 180 degrees clockwise, move down 2 quadrants, so everything in quadrant 3, which is where this is, 1, 2, 3, everything is negative. This is going to be negative something, negative something. And then every 90 degrees, x and y switch places. That doesn't really matter here because 5 and 5 are the same, so it's just going to be a negative 5, negative 5. So there's that point there. Call this A prime. So let's pick one that's not quite so simple. So what if we go to B? So B is at 7, 3. And B prime. Again, down in quadrant 3. So negative something, negative something. So we're saying every 9 degrees they switch places. But if we go 2 quadrants over, that means they switch places 2 times. So if we switch these places twice, they end up back in their original positions. This is going to be negative 7, negative 7, negative 3. Point B. Okay? And we could keep going all the way around to get our remaining points. 5, 1. So 1, 4 would become 4, 1. Wait, no. That's not right. What did I say? 1, 4. We go to negative 1, negative 4. Sorry. And then 1, 2, we go to negative 1, negative 2. So we end up with this shape right here. So C prime, D prime, E prime. We didn't really need to do that because if we look, it's not about the points, it's just what it looks like. So F says pentagon is congruent to the new pentagon. Well, if we're just rotating it, it doesn't change size. This is absolutely true. This is the correct answer. It could have been done from there. Rotations don't change size. Let's see. G, let me check these other ones just to see how wrong they are. The sum of the angle measures is 180 degrees more than the sum of the angle measures of the original. So this never happens. There's no transformation we've done in 8th grade that will add 180 degrees. The only way you can add 180 degrees is if our new pentagon had an extra side to it. And then it wouldn't even be a pentagon anymore. It would be a hexagon. The only way you can add degrees to a shape is you have to add more sides. And that is definitely not what happened here. And then the last two, one of them says it gets twice as big, one of them gets half as big. Both of these would be examples of dilations. And we didn't dilate it, we rotated it, which just changes its orientation and where it's located. So our answer is F. Okay? Alright, 33. 33. Measure of two angles, 5x plus 24, 9x minus 17. What's the value of x if these are congruent? So if the angles are congruent, then their angle measures must be equal. Okay? So now if you had your calculator, you could put this into the calculator. Say n solve 5x plus 24 equals 9x minus 17, comma, what we're solving for, which is x. And the calculator will turn that into an answer. Since I don't have a calculator that can do that with me, let's do this by hand. So let's put our x's all on one side. So let me move this 5x over because it's smaller. So minus 5x from both sides. So this cancels out. So we have 24 equals 9 minus 5 is 4x minus 17. And if we got bored, we could put this into nsolve. We would still get an answer. But let's keep simplifying. So let's move this number to the other side, because now we want to get x by itself, right? So we simplify, so there's only one x, then we get x by itself. So we get rid of minus 17, do the opposite, which is to add 17. So this would be 41 equals 4x, because this cancels out. And then to get rid of times 4, the opposite of multiplying is to divide. So 4 divided by 4 is 1. 1x is just x. 41 divided by 4, that's 10 and a quarter. Which is this answer here. And then if we wanted to, we could go back, we could check this. We could put 10.25 at any one of our steps here and substitute it in, work it out, and we'll see that our left side of our equation is the same as the right side. So that's it. Either nsolve or work it out by hand. Alright, 34. Rectangular prism's dimensions are given, shown in the diagram, not given, shown. What's the total surface area of the rectangular prism in square inches? Place your answer in the bubbles. So it's surface area with decimals and bubbles, right? So this is like the STAR test saying, guess what? We don't want you to get this question right. This is a big old combination of stuff that 8th graders are not good at. But that's okay, because we're here to work on this together. So we start off, it's a shape, right? It's asking us to solve something about the shape, which means we need our formula chart. So we flip back in our book, we find our formula chart. Where's my formula chart? Oh, there it is, right here. Okay, how convenient. Okay, so I'm looking at my formula chart. I see it says total surface area. Whoops, I crossed it out. Try again. Total surface area of a prism. So I find the surface area. I find prism. I see lateral and total. This says total. So this right here, this is the formula we want. Okay. As a side note, if the question just said, what is the surface area? It still means total. Okay. The only time we solve for lateral surface area is if it specifies solve for lateral. So if it just says surface area, it means total. If it says total, it means total. Okay? Almost all the time. If you're not sure, go with total. Okay? So total surface area, S equals PH plus 2B. That's on the formula chart. Then we need to remember, okay, S probably stands for surface area. That's the heading it's under. But what about capital P here? Well, remember that is perimeter of the base. And related to that, big B is the area of the base. Okay. So we need to solve for both of these before we can solve for the main formula. Okay. So we got like 3 different things happening here. Like I said, not easy. So first thing we gotta do is we gotta figure out which shape is the base. Keep in mind I didn't say which number is the base. Please don't tell me the base is 8.2. Right? The base is a shape. And since it's a rectangular prism, the base gets to be some rectangle. Now we can pick any of these because a rectangular prism is all rectangles, but let's keep it simple and say the base is the bottom. Okay, so I'm going to draw this. Where do I want to draw this? Let me draw right here. I'm going to draw a rectangle, not to scale, just so I can see it. And I'm going to label it 8.2 and 3.4. And from there, I can find capital P and big B. So perimeter of anything is just all the sides added up together. Don't look for this on your chart. It's not there. Perimeter just means add up the sides. We have 8.2 plus 3.4. That's 2 sides. We have 2 more. It's a rectangle. They're all the same. It's 8.2 plus 3.4. So work that out. This would be 11.6, and then another 11.6. So that's 23.2. Actually, let me check my calculator here, because I don't want to mess this up and then you all get the wrong answer and blame me. So 8.2. Okay, 23.2. Good job, me. Okay, area of the base. If you forgot the formula, it's right up here. Kind of cut it off. That's circle, and here's like trapezoid, and then rectangle, and is rectangle and parallelogram on the same line? I think it's the same line in 8th grade. Whatever. And it says area equals base times height. Ooh, there might have been triangle in there too. I don't remember. Look at your formula chart. You can see it. Trapezoid's half base 1 plus base 2 times height. Unrelated to the question. We just need this one here. Area of a rectangle is base times height. Or in our case, 8.2 times 3.4. Okay. So go back to the calculator, because I don't want to work that out. So 8.2 times 3.4 is 27.88. You say, can we round that? So yeah, you could, but we're not going to. Okay? Because it's griddable. We can't round it all. We don't want to round when it's griddable. We need an exact answer. Can't even be off by 1/100th if it's a griddable. Okay? Star test don't care. It's got to be exactly right. And hopefully this will work out to a whole number in the end. Okay? So what's left? Found perimeter of the base. Found area of the base. Just need h. So h is the height not of our base rectangle, but of the whole prism. So we come back to the big picture. We say, how far is it from our bottom to our top? Which happens to be this number we haven't used yet. So h is going to be 2. Okay? Now once we have all of that done, then we're almost finished. So we fill in our numbers. So p is 23.2 times the height we said was just 2 plus this 2. This is just a number. 2 times area of the base is because there's 2 bases on a prism. So times, we said area of the base was 27.88. So we go back to the calculator one more time. So let's say 23.2 times 2. That gives me 46.4. Really, you could do all this in one step, but just to be on the safe side, I'm going to split it up a little bit. So 2 times 27.88 is 56 points. No, that's not right. And also not in blue. 55.76. We add these two together. It's 55.76 plus 46.4 is 102.16. Okay? And that would be inches squared, but we don't need that part because it says in inches squared, so all it wants is the number. So we grid that in. This one's actually an easier one to grid in because the decimal's there, right? It's not really a whole lot of guessing where the decimal goes when it's there. We're looking at it, right? And if you wanted to, there's a little plus or minus. You can bubble in the plus if you want to. Optional. Okay? That was the hardest question. At least in this part. Maybe the whole test. Shapes are difficult, man. Good thing we got calculators to help us. Alright, so let's take a step back. This one's a lot easier. Which point on the line best represents the location of square root of 92? So you can go to your calculator. You can hit Control, the yellow button, and then the button that says x squared, and that'll make your radical appear. This division house with a little line on it. Then you type in 92 and hit enter, and that turns it into an answer. Okay? But let's do this kind of old school. So back in the day, we had to do this on calculators. And we had to know what square root would give us these whole numbers. So we'd have to think, what number? No, I got that backwards. 8 times 8 is what number? Which is 64. Which means the square root of 64 equals 8. Because that's what square root means. One number times itself equals this. Okay? And then 9 times 9 is 81. And then over here, 10 times 10 is 100. So we wanted to know, where does the square root of 92 fit in? Okay. So we have this number m, it's a little bit less than 9, so this would be like the square root of 80, right? A little bit less than 81. And then this one's a little bit more than 81, so it's about square root of 82. And then q, a little bit less than 100, but it's actually about the same distance. You'd say it's like the square root of 99 or 98. And then this one that's right at like 9.5, right? And this would be about 92. Okay? So that's our answer, point B. And if we wanted to, we could just put this in the calculator and say square root of 92 is approximately 9.59. And then you say where on the number line is 9.59, and again it's a little bit more than 9.5, less than 10. Nothing to it. Control x squared gives you square root. It's the opposite of squaring a number. Don't miss these ones. As much work as this was, this isn't. Okay? These are the cupcake questions you got to get right. Alright, scatter plot. 12 people learning to type. Okay, cool. Based on scatter plot, what's the best prediction of a person typing speed if they've spent 70 hours? So there's 50 hours. So 60 would be about here. 70 would be somewhere off the graph. Not too far off the graph. We probably could just drawn a line and then gone over, but let's work a little bit harder than that. See if I can make this a bit bigger. Let me put these back. Okay. So the key to a scatter plot is we have to make a line to represent our data. So we're going to try to draw this best we can. That's not great. I can do better. Well, maybe a little bit more. Yeah, that feels pretty good. So you see, not all the points are on the line, but it's a pretty good representation of the line. So let's pick a couple points. Let's say 50, right? That's towards the end. 50 is right about here. Somewhere between 60 and 65. But for the sake of keeping this simple, let's say it is 65, right? So we're rounding anyway. It doesn't have to be perfect. So 50 hours is about 65 words per minute. Okay? And we know the point that we actually care about is at 70 hours. So it's at 70, comma, we don't know yet. Okay? But how far apart are 50 and 70? Those are 20 hours apart. Right? So what if I went the opposite direction and said, what's 20 hours before 50? And said, where am I at 30 hours? So if I go up to 30, and then over, right? I get a little bit more than 40. But let's, again, keep it simple. Let's call it 40. Okay? Why not? So now we can see what happened to our words per minute. So right here, it went up by 25. So here, we would expect it, since it's linear, to go up by another 25. This is plus. So if we take 65 plus 25, that would give us about 90. So then I go down to my answer choices, and I check to see if any of these are reasonable. So 55, definitely not, because we already passed that. 70, it's a little low. So you have 85 and 100. So both these are kind of close. 85 is definitely closer. I think this is the right answer. I'm going to stick with that one. Proud of that. If it comes out kind of close, you might double check your line and make sure. But I mean, these aren't really that close. 100 would be right here. But I only want, oops. I want to go about there, and that's, yeah, look at that. We're about 85. Okay. So you find a couple points, look for the rate of change, figure out a number, and then pick closest one to it. Go with your heart. Okay. Let's see, 37. Carolyn buys same number of stamps. Okay, cool kid, cool kid. Her grandfather gave her. Oh, that's actually sweet. Table shows the number of stamps she has at the end of X number of months. So how many stamps was she given, and how many will she buy each month? Okay, so this is a fancy way of saying, do you understand equations? Or y equals m. That's not an m. mx plus b. Right? Where m is always slope, b is always the y-intercept. Because that's what it's asking you for. Didn't use any of those words, but it did. It says, how much was she given? What you're given, if someone gives you something to start your collection, this is where you began, right? So it's asking, how much did she have at 0 months? So it's asking for the y-intercepts, right? And when it says, how many will she buy every month? Here's your keyword, every. This is a rate. So a rate of change is just a fancy way of saying slope. So it's asking you, what is the slope? What is the intercept? Which are things we can find. So let's do that. So our change in y here, from 1 month to 3 months, number of stamps went up by 100. Okay. Number of months changed by 2. Okay. So our slope, m, is 100 stamps every 2 months, or if we simplify that, 50 stamps per month. Okay, and that narrows it down, right? That gets rid of B, that gets rid of D. Now we just need to know, did she start at 180 or 200? And we can use a little bit of common sense. If we look, 250, 350, 500, 700, those are all multiples of 50, so it's probably going to be 200. We can also say that since the slope is 50, if we look at the change from where she started to that first month is a change of 1 month, and every 1 month it went up by 50. So what would she had to have start with if we added 50 to it and ended up with 250? So 250 minus 50, you guessed it, is 200. So she had to have started with 200, picked up 50 more each month. Okay. If it wasn't this simple, right? If it didn't give us 1 and asked for a 0, we also could have said that our equation, mx plus b, right? And we figured out that the slope was 50. And we wanted to know what b is. So if we pick some value of x, let's say 10. 10 is a nice number to work with. So 50 times 10 should equal 700. But 50 times 10 is 500. So what would we need to add to 500 to get to 700? And you guessed it, it's 200. There's a couple different ways we can come up with the y-intercepts. Again, pick the one you like best. Or you could always graph it, write some graph paper, plot these points, and then wherever that graph crosses the y-axis, that's your intercept. That's it. Alright, 38. What's the mean absolute deviation? Okay, so mean absolute deviation is just the, not abs. I don't know where I'm going with that. It's the, just reading. Mean absolute deviation means average distance from the mean. Okay, this is a 3-step process. First thing we have to do is we have to find the mean, which is the average. Okay, which means we have to add these 5 numbers up and divide by 5. And I'm going to take a guess and say that our mean is either 34.4 or 38.4. Because otherwise, why would these answers be here? Which means don't pick either of these. I am absolutely certain neither of those are correct. I have not touched this problem. Okay? Because mean deviation is almost always going to be smaller than the numbers you began with. So let's check. So 32 plus 43 plus 38 plus 28 plus 51 divided by 5. 38.4. Hey, how about that? So this right here is our average, or our mean. So what we do with that is we take each of these numbers and we subtract it from 38.4. So we're going to say, what's 38.4 minus 32? And then 38.4 minus 43. And then 38.4 minus 38. 38.4 minus 28. Hopefully you start to see the pattern here. Minus 51. And this is going to give us a new list of 5 numbers. Okay, so I start putting these in the calculator. So 38.4 minus 32 is 6.4. 38.4, whoops, that's not my calculator. I know what the answer is to these, but I never feel confident when I subtract and get negatives. I feel like I'm going to do it backwards. So when I put in the calculator, it does give me 4.6. Negative 4.6, because I'm taking a bigger number away from a smaller number. Right? But since it says absolute deviation, absolute means like distance, right? Which is always a positive number. So we're going to ignore the negative part. I'm just going to write down 4.6. Okay? So we're only putting positive numbers here. Otherwise, when you take the average, you always get 0, which is not what we want. Okay? So only positives here. So 38.4 minus 38 is 0.4. This right here, this would be 10.4. And 38.4 minus 51, negative 12.6, or just 12.6. Okay? So now I'm going to take the average of these 5 numbers. Okay? Let's see what we get. So 6.4 plus 4.6 plus 0.4 plus 10.4 plus 12.6. Oh, 34. Okay. So that's where this came from. When we add these 5 numbers up, we add those up, we get 34.4. So hopefully, this would be really sad. If you did all this work, added them up, got 34.4, and said, boy, I did all this work, I'm going to pick this one because I see it. That'd be so sad because you're almost finished. You just have to remember that we need to take that number and divide it by 5. And we get 6.88. Wow. That would be sad. I hope no one picked F after doing the work. That would bum me out. So 34.4 divided by 5 equals 6.88. So each of these 5 points is about 6.88, about 7 away from the average of 38.4. Okay? That's it. That's just calculator work. A little bit of memory. Okay, linear relationships between charges for trip, number of miles driven for 2 taxis. Which statement appears to be true? Okay, so let's just go down the list and check what our answers say. So charge for trip with a distance of 5 miles. Okay, here's 5 miles. At 5 miles, the lines cross, which means taxi 1 and taxi 2 both cost $20. So can the cost for taxi 1 be more than taxi 2? No, because we just said they're the same. Can the charge for taxi 1 be $5 less? No, we just said that they're the same. Charge for both of them is $20 for A and B. Okay, that's what we just said. And then D, the charge for 1 and 2 cannot be determined. We did determine it. It's right here. It's $20. This doesn't make sense. Don't pick this one. Please don't pick that. Answer C. Okay? So key here, where the two lines meet is where they're exactly the same, which happens to be the point we cared about. Okay? Nothing to it. Alright, 40. Which scatter plot suggests linear relationship between x and y? Okay. This is not too bad. We can just draw pictures. So let's say, what's our pattern here? So this one starts out kind of slow, then gets kind of quick. That's not linear. That's exponential. This one here, well, this one looks pretty good, right? Positive looking thing. This looks like a maybe. This one here, roller coaster, goes up, goes down. Okay, non-linear. And then this one, it's like a constellation or something. It's I don't know what it is. I thought it was gonna be a dog for a second, but couldn't make it happen. I don't know. This is nothing. This is no association. And if there's no association, then it can't be linear. So our only good answer is B. That's it. I'm not really sure what kind of work you can show for that. You just have to draw through the points. And our last one. Oh my goodness, we're almost done. Which graph represents y as a function of x? If it's a function, x does not repeat. So there's no numbers here. So it's hard to like just look at a list and see where x repeats. So what we can do is if we drew a red line, make it skinny. Yeah, there we go. If we drew a line going straight up and down, this represents one x value, right? This is where x equals 4 right now, right here. Everywhere on the line, x equals 4. So in order for x to not repeat, I should be able to put, I'm going to erase this because we're going to move the line. I should be able to put this line anywhere on the graph, and it will only hit our graph one time. Okay? Whoops. Lock this one in place. Hopefully you figured out what the answer is by now. Well, we're going to go over it anyway. So if I take this one here, anywhere I put this, we can see that we hit the line at two separate places, right? Which means x is repeating pretty much everywhere. So this one's no good. I didn't mean to put x there, because then it looks like just x axis. This is wrong. Okay. So let's skip G, because that's the right answer. Letter H, that is a vertical line. So all the points on this, x repeat, right? Just don't pick this one. This is terrible. X repeats, absolutely. And then J, a circle is a circle of function. And you'd say, no, it is not. Because again, on any point on this line, or anywhere on our circle, it crosses each x value at two separate places. So x is repeating everywhere. Okay? So the only one where it doesn't repeat anywhere is this kind of goofy looking relation here. So I can slide this over. And everywhere we hit x at exactly 1 point. And that's what we want. That's what a function means. That any x value we pick has its own unique y value. That's what it means to be a function. And with that, you now have one completed benchmark, and hopefully you're ready to pass STAR test. Alright. That was fun. Ish. Okay, good night.